All right, thank you so much for joining us today. So in this video, we are going through 30 multiple choice questions on vector algebra in preparation towards our final exams, right? So let's jump right in. Now, the first question is asking us to find the volume of a tetrahedron, right? So the formula that we just need from here, we just need the formula. So the formula for this is equal to 1/6 of the volume of a parallelepiped, or let me say a parallelepiped. So that is basically what we just need here. So the volume of a tetrahedron is equal to 1/6 of the volume of a parallelepiped. That's what we just need here. Now, what is the formula for finding this? Now, they've given us O of D, O of E, and then O of F. And we know that the volume of a parallelepiped is basically the scalar triple product. So this is going to be equal to 1/6 of OD dot OE cross OF. So that's what we just need, right? Now from the question, OD is equal to 1 minus 3 minus 1, which is the same as I minus 3J minus K. And then OE is giving us 343 or 34 minus 1, which is the same as 3I plus 4J minus K. Then OF is giving us 1. So this is the I will just go. So I'm going to have 3J plus K. So this is what we have. So we can start by doing the cross first. So we can start by finding for OE cross OF, which is equal to, so we know how to do this. This is I, J, K. Then the second row will be the first one, and the last row will be for this. So I'm going to pick the coefficient of this. I'm going to have 1, minus 3, and minus 1, which is the same as what is here. Then I'm going to pick 3, 4, and I'm using this here and this here. So I'm going to have 3, 4 minus 1, and then 3, 1. So that's what I'm going to get from here. Now let's try and do the cross, and then we just go. So don't forget the cofactors. I'm just writing the top because we are using the top. So this is going to be I, then 4 minus 1, 3, 1. So cross this and this. This one will be left with this, what is here. Then minus J, I'm going to have 3 minus 1, 0, 1. So when you cross this and that, and then last one is plus K, I'm going to have 3, 4, 0, 3. The same thing, cross this and that. It will be left with this one, which is also here. So let's try and expand this. Let us try and expand this. So this is going to give us I 4 plus 3, right? So this time this will be 4. Then this time this will be minus, but we have minus, so it's going to be plus. Minus J, this is going to be 3 minus 0, and then plus, this is going to give us K3 minus 0, 2 again. So this is going to give us 7I minus 3J plus, okay, this one's supposed to be 9, yeah, I think. And then this is going to give us 9K. So this is for OE cross OF, right? Now, when we are done, we need to dot it with what? OD. So let's do that. We are going to have OD dot OE cross OF. So I can just put vector on them. Let me put vector on them so that you can get the vectors. Good. So this is what we are going to get. So now let's do the dot. What is OD? OD is I minus 3 So we have I minus 3j minus k for OD, and then the one that we just did is also here, which is 7I minus 3j plus 9k. So let's do the dot. So for the dot product, we just go direction by direction. So this is going to give us 7 plus 9 minus 9, and this is going to give us 7. So that's what we are going to get at the end of this. So now this is giving us 7. So it means that finally we are going to have the volume to be equal to 1 divided by 6 times 7. And this is going to give us 7 on 6. So let's check if we have the results there. Okay, so we don't have any of them here. It's just this, but this one is the volume of a parallelepiped. So we cannot choose this one. So no option from here. We don't have any option from here. All right. Now let's look at question 2. Now question 2, we want to determine the point of intersection of the line, this and that, right? So that's basically what we just need to do. So we can see that this line here is going to be in terms of mu. So let me see, my first line is in terms of mu. So when I multiply the mu throughout, or even if I maintain it, I'm going to have 2I plus j plus 3k, and this is the same as 2 mu I plus mu j plus 3 mu k. So this is what I'm going to get. And then my other function too is in terms of t, right? So let me assume that this is n. So I'm going to have n of t because it's in terms of t. So I'm having 1 minus t minus x I plus 4t j minus 3xk, right? For intersection, we need to equate this and this. Then we find for mu, we just do substitution and we get the point. So let's see what we are going to do here. I'm going to equate this one to this. So for intersection, this should be the same as this. So I'm going to have 2 mu I plus mu j plus 3 mu k, which is equal to 1 minus t minus s I plus 4 tj minus 3sk. So what we are going to do here is we are going to compare directions. So I have I, j is here, and then k is here. So this implies that 2 mu is equal to 1 minus t minus s. So let me call this one equation 1. And then I have mu, which is equal to 4t. Let me call this one equation 2. And I have 3 mu, which is equal to minus 3s. Let me call this one equation 3. So what we can do here is we can just pick from some of the equations and then we try to solve, right? So for example, when I look at, let me say, equation 2, from equation 2 like this, we can make t the subject. So from equation 2, we are going to have mu is equal to 4t. This implies that t is equal to mu over 4. Now here we want to make sure that we make t and s the subject so that we can find for mu and then we solve. We can also get mu from equation 3, right? So from equation 3, we have 3 mu, which is equal to minus 3s. So I can make s the subject, and I'm going to have s to be equal to 3 mu divided by minus 3, and this is equal to minus mu. So let me call this one, let's say, equation 4, and let me call this one equation 5. So now that we have gotten t and s, we can plug it inside equation 1 so that we can find for mu. So let's do that. Put equation 4, equation 5 into equation 1. So what are we going to get here? We are going to have 2 mu is equal to 1 minus t. T is mu on 4. Then minus s, but s is minus mu. So let's try and find for mu. So 2 mu is equal to 1 minus, oh, this one's supposed to be 4. then mu over 4 plus mu. So let me multiply through by 4. So I'm going to have 8 mu is equal to 1 minus mu. No, this one's supposed to be 4. And then plus 4 mu. So 8 mu is equal to 4 minus plus 3 mu. When I move, I have 8 mu minus 3 mu is equal to 4. And then 5 mu is equal to 4. And then mu should be equal to, I think, 4 on 5. 4 on 5. So now that we have gotten mu, we can go to one of the equation, right? So we have one of the equation, they are the same. So I can put it inside this one and then see how we are going to get our functions. So we know that we have one of the function, which is r of mu, which is equal to 2 mu I plus mu j plus 3 mu k. So let's try and then put mu inside. So we are going to have 2 times 4 over 5 I plus 4 over 5 j plus 3 times 4 over 5 k. Let's simplify this and we are getting 8 over 5. Is it supposed to be over 5? Yeah, 8 over 5 plus, no, I plus 4 over 5 j plus another 8 over 5, no, 12 over 5k. So this is the same as 8 on 5, 4 on 5, and then 12 on 5. So let's go and see. The denominator is the same, which is 5, 5. We have 4, we have 8, 4, 5. So let's go and see the point with 4, 8, no, 8, 4, 5. 8, 4, 5 is going to be this one. So we have 8, 4, 5, sorry, 8, 4, 12. Yeah. So that's what you are going to get from there, which is question 2. Okay. Now let's look at question 3. So I think I need to say this one again. I need to say this again. Anytime you are solving, make sure you watch the solution before, your answers before you do them, right? So here we want to find the normal vector to this and that, given that A is this, B is this, and C is this. So what we are going to do is, we just need to find A minus B and then B plus C. And when you talk about normal vector here is equal to, so let me see, vector normal here is equal to A minus B cross B plus C, right? So that is the vector normal. So what we just need to do is, let's look for A minus B and let's look for B plus C. So A minus B is equal to I plus j minus k, minus b is I plus 2j plus 2k. So multiply through by minus and we are going to have I plus j minus k minus I minus 2j minus 2k. So this is going to give us, now I will be 0, and then this is going to give us minus j minus 3k. So this is what you are going to get from A minus B. Let's look for B plus C. So what is B? B is I plus 2j plus 2k, and then C is minus I plus 2j minus j. So when I do that, this is minus, so this and this will be 0, this and this will be 4, and this will be 1, so plus k. So this is what we are going to get. So now that we have gotten this, we want to do the cross, right? We want to do the cross. So let me just pick this one and bring it down there so that we can see what we are going to do with the cross. So this is going to be like this. So we know that A minus B is equal to this, so I can replace it by that. So minus j minus 3k cross A plus B plus C is 4j plus k. So remember, this is cross product, and cross product, we need all directions. We need I, j, k before we can do it. So this is going to be equal to I, J, K, and then the first one will occupy the second row, the last one will occupy the last row. So this one, there is no I, so we are assuming that the I part is 0. We are going to have -1 and -3. This one to no I, so we are going to have 0, 4, and 1. So let's just go through the process. I'm picking the direction, the top, so plus or minus, like this. So I'm going to have I. Then when I cross this and that, I'm going to have -1, -3, 4, 1. Then minus j, when I cross this and this, I have 0, -3, 0, 1, plus k. Then when I cross k like this, I have 0, -1, 0, and 4. So this is what I'm going to get from this. Then I can write this one as I, multiply this to this, so we are going to have -1 plus 12, right? And then minus j, this one will be 0 minus 0 plus k, 0 minus 0. So this is going to give us 11i, because all of this is going to be 0 from this. So let's go and see if we have 11i there. Okay, so we don't have 11i, so we can choose to have D, none of these. Okay, none of these. Okay, so now let's look at the next question. So the next question, we want to find, what do we want to find? We want to do the same thing, A cross B dot A cross C. So first we need A cross B. So A cross B is equal to, we just did sum. So I, J, K, A component here and B component here. So we are going to have the coefficient 2, 3, -1, and the B is going to give us -1, 2, and -4. So that is the A and B component. So let's try and then figure out the values. So plus, minus, plus. So this is going to give us I. Then cancel it. You are going to have something like this. 3 -1, 2 -4, minus J. We are going to have 2 -1, -1 -4, plus K, 2, 3, -1, 2. So this is what you are going to get. Now let's do the multiplication. So by this time you should be very good with these things. So this is going to be -12 plus 2, right? Minus J, this is going to be -8 minus 1 plus K, and this is going to be 4 plus 3. So this is -10i. This is going to give us plus 9j, and we have 7k. So this is A cross B. The next one is A cross C before we do the product, dot product. So we need A cross C. So I, J, K. A component first, 2, 3, -1. So 2, 3, -1. And then C component is 1, 1, 1. So let's do that. This is going to give us I, 3 -1, 1, 1. Don't forget this one should be minus. Then this is going to be 2 -1, 1, 1. And then plus K, we are going to have 2, 3, 1, 1. So let's see what we are going to get from here. I goes with 3 plus 1, right? Minus J. Then we are going to have 2 plus 1 again. And then plus K. This is going to be 2 minus 3. So when we simplify this, we get 4i minus 3j plus minus k. So now we've gotten A cross C and then A cross B. So now we need to find the dot. So A cross B dot A cross C. So this one we had -10i plus 9j plus 7k dot A cross C, which is 4i minus 3j minus k. So this is what we are getting. So now let's do the dot product, direction to direction. So -10 times 4 is -40. 9 times minus 3 is minus 27. And then 7 times minus 1 is minus 7. And this is going to give us minus 74. So this is what you are going to get. Let's go and check if we have minus 74 in the results. Okay, we have it here. So this is how we need to go through process. It's very simple when you understand them and you are doing them step by step. Now let's look at this question that we have here. So this question is asking us to find the angle between A and C, given this information here. And then when you finish, we figure out this one and then the triangle too. So let's start with the 5. So for us to find the angle between A and C, we need to know the formula first, right? So the angle between A and C should be A dot C is equal to the magnitude of A, magnitude of C, cos theta, right? So if I want to know the angle, then I can say that cos theta is equal to A dot C divided by the magnitude of A, magnitude of C, and theta should be equal to cos inverse of A dot C divided by the magnitude of A, magnitude of C. So what we need A dot B, A dot C, and then the magnitude of A times magnitude of what? C. So let's do that. What is A dot C? A dot C. So what's the component for A? 1, 3, 2. So I plus 3J plus 2K. So this is the component for A. Let's look at the component for C. Minus 1, 2, 3. So minus I plus 2J plus 3K. So let's do the dot. We are going to have this times this is going to give us minus 1 plus this times this is going to give us 6, and then this time this is going to give us something like and also 6. So this is going to give us 11. Yes, what is true. Now the next thing that we need to do is now we need the magnitude of A, the magnitude of what? C. So what is the magnitude of A? So the magnitude of A is just picking the component of A and then squaring them. So we have 1 squared plus 3 squared plus 2 squared, right? And this is going to give us square root of 1 plus 9 plus 4. And then this is going to give us square root of 14. Good. Now let's look at the square. Let's look at magnitude of C2. We are going to have something like minus 1 squared. So minus 1 squared plus 2 squared plus 3 squared. And this is going to give us 1 plus 4 plus 9. And this one also is going to give us square root of 14. So we can decide to even look for magnitude of A, magnitude of C, square root of 14 times square root of 14. And this is going to give us 14. So now we know 11, we know 14. So theta is equal to cos inverse of 11 divided by 14. And this is going to give us something like this. When you point it on the calculator, you should get 51.79. That's what you are going to get. But let's see if we have the results there. Okay, we don't have the results. So what we can do is we can subtract it from 90, right? So let's subtract the angle from 90. So 90 minus 7, this should be 38.21. Yes. So let's see if we have 38.21 there. 38.21. Yeah, we have it here. So that is the angle. So here, what you just need to know, from here is just knowing the formula and then just doing your dot and then finding the magnitude, and you are there. Now let's look for AB and then vector AC, right? So vector AB is vector AB. So this is question 6, right? I think. So vector AB is equal to OB minus, or let me say small b minus small a. So what is small b? B is 2 minus 1, 1. So 2 minus 1, is it 1 again? Let me check it. Yeah, 1 again. So plus k. So let's do that. Plus k minus, what is a? A is I plus 3j plus 3k. So that is A, right? Yes, that's true. So now we can now do the subtraction. So 2I minus I is going to give us I. Minus j minus 3j is going to give us minus 4j. And then k minus this is going to give us minus 2k. Is that right? Okay, let me see. What is A? Is it 2 or 3? Let me see. Okay, this one's supposed to be 2. So this one is supposed to be 2. So this is going to be just minus k. So this is what you are going to get for A, vector AB. Let's look for vector AC. So vector AC is C minus A. C component is minus 1 plus 2j plus 3k. That's for C. Minus, we have the A here, which is I plus 3j plus 2k. So let's do the subtraction. This minus this is going to give us minus 2i. This minus this is going to give us minus j. And then this minus this is going to give us plus k. So what we need vector AB cross vector AC. So let's do that. We need vector AB cross vector AC. So I, J, K. So AB is 1 minus 4 and minus 1 from this side, right? This one. And then AC is from here. So we are going to have minus 2, minus 1, and 1. So let's now enjoy. So I, minus 4 minus 1 minus 1 1 minus j, then 1 minus 1 minus 2 1 plus k, 1 minus 4 minus 2 minus 1. So you can confirm this and this here is what is here. This and this one and this one are here, and then this and this also here. Okay, so this is minus 4 minus 1 minus j. This is 1 minus 2, and then plus this is minus 1 plus minus 8. So this is what we are going to get from doing it. So we are going to have minus 5i plus, so this will be minus 1. Minus 1 times this one is going to give us plus j, and this is going to give us minus 9k. So minus 5, 1 minus 9. Minus 5, 1 minus 9. So the answer is A. Minus 5, 1 minus 9. So we are going to get from this one. So the questions are very simple. You just need to know how to do the cross and how to get vector AB and AC. Last one, we want to find the area of the triangle, right? So the area of the triangle is basically area of the triangle is equal to 1 over 2 of vector AB cross vector AC magnitude. So fortunate for us, we have this one already, which is here, and the final answer is this. So all we just need to do is we need to find the magnitude, then we take it from there. So what is the magnitude of AB cross AC? So I just pick minus 5 squared plus 1 squared plus minus 9 squared. What are we going to get? So we are going to have square root of 25 plus 1 plus 9 squared is 1. Then add them, you're going to get 107. So the area of triangle is equal to 1/3 of 1 second, 1 over 2 of 107. So when you point this one on a calculator, you're going to get something like 5.17 square unit. So let's see what are we going to get here. 5.17 square unit. So we are going to get B here. All right, I hope you are enjoying it. Let's try hard for our final exam. And let's look at question 8. let's look at question 8. So if a line is passing through the C and is parallel to B, so now we want to find the equation, right? What is the equation of the line? So this one, we have 2 points. So equation of the line, we can write it r of t is equal to, let me say, c plus bt. Now, how did I know that I need to multiply b to the t? Because we are saying that the thing is parallel to b. So my point is the original point, and then this is the one which is giving us the direction. So we are saying that this is the directional vector, so we need to multiply by t, right? So it's very simple. So what we just need to do here is we just have c is minus 3 4 2, and then plus b is 1 minus 2 minus 1 t, multiply the t through minus 3 4 2 plus t minus 2t minus t. And guess what? Now remember, this is ijk, this is also ijk, so we can add them and have something like this. Minus 3 plus t as one component, and then 4 minus 2t as one component, and 2 minus t as one component, because they are all, ijk, right? So now don't forget, r of t2 can be written as x, y, z. X, y, z in the form of like vector form. So don't forget, this is I, J, K, but I'm writing it in the vector form. And this one too can be written as minus 3 plus t, 4 minus 2t, and 2 minus t. So now we can compare component by component. So here x is equal to minus 3 plus t. This implies that t is equal to x plus 3, right? And then now let's go to y is equal to 4 minus 2t. This implies that minus 2t is equal to y minus 4, and t is equal to y minus 4 divided by minus 2. Is that right? Yes. And then z is equal to 2 minus t, and this implies that minus t is equal to z minus 2, and t is equal to z minus 2 divided by minus 1. So let's go and check the results before we compare anything that we want to do. So we see that this is t, so we have x minus 3, sorry, x plus 3, which is equal to, this is also t, so we can write this one as y minus 4 divided by minus 2, and this one too is also t, so we are going to have z minus 2 divided by minus 1. So let's check the results before, if we just need to do any manipulation, we can do that. So we don't have anything like divided by. So what we can do here is we can multiply through by minus 2, right? So that we will see what we are going to get. So let's multiply through by minus 2, and we are going to have something like this. Let me see the results that we have here if we need to multiply through by minus 2. Okay, we can do that. So multiply through by minus 2, and we are going to have something like this. Or I can write this one as x plus 3. Then this minus will multiply the top. So I'm going to have minus y plus 4 divided by 2. Let me make it positive from there. And this is minus z plus 2. So now I can multiply through by 2, and I'm going to have 2x plus 6, which is equal to minus y plus 4, which is equal to, I can write this one as 2 minus z. Is that right? Yes. So I can rewrite this one as, let me say, 6 plus 2x, which is equal to 4 minus y, which is equal to 2. Oh, I should multiply this one through by 2, right? Because I'm doing by 2. So this one should be minus 2z plus 4. So that now I can write this one as 4 minus 2z. Good. So let's go and check if the answer that we've gotten is up there. So let me just copy and go and paste it up there and see if we have the answer there. So let me paste it here, and let's compare which one is. So 3 minus x, no. 6 plus 2 is here. 4 minus y is also here. And then 4 minus 2z is also here. So we can pick the b straight away from here. Yes, indeed, that's right. That's true. So that is what you are going to get for the question 8. Now let's look at question 9. So question 9, the question wants us to find the angle between the planes, right? So for us to find the angle between the planes, we need the vector. We need the normal vector first. So from 2x minus y plus z is equal to 13, we are going to write out the normal vector from this. So let's assume that the first normal vector is n1. So remember, s goes with I, y goes with j, and z goes with what? K. So we are going to have 2i minus j plus k. So we pick the coefficient. This, we just ignore it. So same thing for if you want to pick n2. So from x plus 2y plus 3z is equal to 0, n2 will be equal to I plus 2j plus 3k. Right. Then we can find the angle. So since we want to find the angle, the same thing, n1 dot n2 should be equal to n1 magnitude, n2 magnitude, and then cos of theta. So cos theta is equal to n1 dot n2 divided by the magnitude of n1, n2, and then theta will be equal to cos inverse of n1 dot n2 divided by magnitude of n1, magnitude of n2. So let's look for n1 dot n2 and then the magnitude 2 as well. So n1 dot n2, n1 is 2 minus this plus k, dot n2 is 1, 2, 3. So I plus 2 plus 3k. So let's do the dot, I to I. So 2 minus 2 plus 3. So this is going to give us 3. Now let's look for the magnitude of n1. So n1, the coefficient is 2 squared plus minus 1 squared plus 1 squared. That is n1 here. So this is going to give us magnitude of 4 plus 1 plus 1. So this is square root of 6, which is true. And then n2 is going to give us final magnitude of this. So 1 squared plus 2 squared plus 3 squared. This is 1 plus 4 plus 9, and this is magnitude of 14. So if you want to find magnitude of n1, magnitude of n2, we are going to have root 6 times root 14, and this is the same as root of 84. So now theta is equal to cos inverse of, we said cos theta is equal to cos inverse of n1 dot n2, which is 3, and then the magnitude. So we are going to have something like 3 divided by root of 84. And then this on calculator is going to give us 70.89. Let's go and check the results. If it's not there, we subtract it from 90. So let's check a 70 point. Okay, we have it here. So we don't need to subtract it from 90. If you subtract it from 90, what are we going to get at the end of the day? We are going to get none of the answer will be here. So we just choose that one and then we are done. Let's look at question 10. Question 10, we want to find the value of x such that A, B, and C are coplanar. So we know coplanar vectors, right? So for coplanar vectors, when we find the scalar triple, it should be equal to what? 0. So it means that A dot B cross C should be equal to 0. This is coplanar, right? So we know that this is the same as, so this one, because of the dot, A will be on the first, this one will be here, and this one too will be here. So A is 5x 2, B is 7, 2, 2, and C is 1, 1, 1. And this one should be equal to 0 because they are coplanar to each other. So let's try and figure out x. So I maintain 5 x, no, 2, 2, 1 minus x. Then I'm going to have 7, 2, 1, 1 plus 2. Then I'm going to have 7, 2, 1, 1. This should be equal to 0. So don't forget I was using plus minus plus for the top one. So positive minus positive. This, is that right? Yes. This, okay. And this one too is okay. So let's do the expansion. 5, 2 minus 2 minus x, 7 minus 2 plus 2, 7 minus 2, which is equal to 0. So this will be 5 times 0. Then this is going to be 5x. 7 minus 2 is 5, so plus 10 is equal to 0. Then minus 5x plus 10 is equal to 0. 5s is equal to 10, and x is equal to a big 2. Wow, so we had 2. So some of them are pretty straightforward. Now let's look at question 11. Let's look at question 11. Okay, so question 11, we want to find the volume of a parallelepiped, right? So this is just a formula work. So volume of pipette. This is equal to how many, this thing that we have here, we have A, B, C. So what we can do is, now we want to find the volume of this and this and that. So this is going to be something like this. A plus B dot A plus C cross C plus A. So this is what you are going to get. So what we can do is, I can give this A plus B as a big A. So I can call this one big A, and I can call this one big B, and then call this one big C, so that I can have it this way. Very simple. So now let me go and look for A. A is equal to A plus B. So let's go and look for A plus B. So A is 2i minus 3j plus 5k, plus B is 3i minus 4j plus 5k. Sum them, 5i minus 7j plus 10k. So that is A. Let's look for big B. B plus C. B is 3i minus 4j plus 5k, plus C is what? 5 minus 3 minus 1. 5 minus 3 minus 1. Good. So this is what I'm going to get. Sum them and we get 8i minus 7j plus 4k. Is that right? Indeed, yes. And let's look for the last one. What is C plus A? So C is 5i minus 3j minus k, which is from here, was the C. And then A is, what is A? 5, no, A is 2 minus 3 and 5. Is that right? Good. So we are going to have plus 2i minus 3j plus 5k. That is A. So add and get 5i. Is it 5, 7i? Sorry. And then minus 6j plus 4k. This is 5. Good. So now we have big A, big C, big B. Let's just try and put them in. So the volume of P, which is a volume of parallelepiped, is now equal to A is equal to A cross B, sorry, A dot B cross C. And this is the same as finding the determinant. So this is going to give us, okay, the determinant will not go here, okay, to go there. This is going to be as like this. So A is 5 minus 7, 10. 5 minus 7, 10. And B is 8 minus 7, 4. 8 minus 7, 4. And C is 7 minus 6, 4. So this is what you are going to get. So what we just need to do is we just need to find it, and then we are done. So let's check it out. Now picking 5, let me just bring this guy here. 5, I'm going to have minus 7, 4, minus 6, 4. minus 7, I'm going to have 8474. And then plus 10, I'm going to have 8 minus 7, 7 minus 6. So what I'm going to get here, I'm going to get something like this. Multiply them 5 times 28 minus, okay, 20 plus 24. This one should be minus. This and this will be minus. Good. Then plus 7. This is going to be 32 minus 28. Yes. Plus 10. And then minus 6 times 8 should be minus 48 plus 49. Good. So this is going to give us 5 times minus 4 plus 7 times 4 plus 10 times 1. This is minus 20 plus 28. This one should be 20. Then plus 10. So indeed, this should be giving us 18. Good. 18 cubic unit. So let's go and see if we had 18 from there. Okay, indeed, we have 18 here. Good. So basically, everything that we are doing here is formula based. If you know the formulas, you should be able to get them through very quick. Let's look at question 12. Question 12. So question 12, we want to find the equation of the plane containing I, J, K. So first we need the formula. So what is the formula here? Ax minus x1 plus by minus y1 plus c z minus z1 is equal to 0. Now our x1, y1, z1 can be any of the point, right? It can be any of the point, but our a, b, c are the normal vector from ijk, right? So let's go and find the normal vector from ijk so that we can just use them. So let's do that. So the normal vector is equal to I plus bj plus ck. So the normal vector this is equal to the coefficient of this with the directions. So now let's try and figure it out. So since we have ijk, we are going to look for ij, right? Vector ij, which is going to give us j minus I. And then we are going to look for ik, which is going to give us k minus I. So that's what we are going to look for. So what is j? J is 4, 3, minus 1, minus what is I? Minus 3, 1, and 1. So this is going to give us, in direction, we are going to have 7, 4 minus 3 is going to give us 7. 3 minus is going to give us, minus 1 is going to give us 2. And then minus 1 minus 1 is going to give us minus 2. So 7, 2, minus 2. K is, what is K? K is 2, 1, minus 8. Is that right? Yes, indeed. Then minus I is minus 3 again, and 1, 1. So this is going to give us 5, 0, and minus 9. Good. So now that we have gotten this and this, now we can find the vector an, right? So vector an is equal to the vector of ij cross ik. So the more you solve example, you get used to the questions for you to go very fast. So ijk, and then the component for this is 7, 2, minus 2. And then the other one is 5, 0, minus 9. So let's try and then figure it out what we are going to get. So we are going to have something like this. As usual, I, 2 minus 2, 0, minus 9, minus j, we are going to have 7 minus 2, 5 minus 9, plus k, we are going to have 7, 2, 5, 0. So this is going to give us I minus 18 minus 0 minus j, and this is going to give us minus 63. 9 times 7 is 63. Then plus 10, because it's going to be minus 10 and make it plus. And then 7 times 0, 0 minus 10. So this is minus 18i minus, no, plus 53j minus 10k. So when, remember, this is this. So when you compare to ai plus bj plus ck, then a is equal to minus 18, b is equal to 53, and c is equal to minus 10. So now we can just put it inside the formula. So we are going to have, the formula is ax minus x1 plus by minus y1 plus cz minus z1 is equal to 0. So what is a? Minus 18, x minus, so let's go and pick any coordinate, right? Let's go and pick any coordinate that we want to use. Good. So let's pick any of them. We can pick like I. So I is minus 3, 1, 1. So let's do that. Minus 3, 1, 1. That is I. We are picking I. Minus 3, 1, 1. When you finish, you can pick, if you are trying, you can pick any formula too. You can pick any of them and see if you are going to get the same result. So this is going to be minus 3 because S1 is minus 3 plus B is 53, Y minus 1, and then minus 10, Z minus 1. So let's go and see the results. The results is expanded. So let's try and expand this. So minus 18x plus 3 plus 53y minus 53 minus 10z plus 10 is equal to 0. So this is going to be minus 18x. What is 3 times 18? That should be 54. Is that right? Yes, I'm sure. 58. No, 54. Because 8 times 3 is 24. Yes, 50. So this is going to give us plus 53y minus 10z. Then when I add, this is going to give us minus 43. So this plus this will give us minus 43. It's equal to 0. And then we are going to have minus 18x plus 53y minus 10z. Then add this one to this, and we are going to have something like minus 90. Is it 7? Yeah, it's equal to 0. So let me just move this to the top and see what we are going to get for the solution. So let me just bring this one down small and paste this one here. And let's compare. Okay. So do you have any constant with 97 first? So no constant with 97. So we don't need to even compare and see if they are right or not. So it means that there is no option because we don't have even this one here. Because if we have it, then we can decide to multiply through by minus and then see what we are going to get. So this is the solution for the function, but there is no option. Let's look at question 13. Now, question 13, we want to find P vector PR cross vector PQ. So maybe I can give you this to solve. Yes, you can do it, I'm sure. Or let's do it and see what you are going to get. Let's do it and see what you are going to get from here. So since we need vector PR cross vector PQ, we know what to do. We need to find for this. This is R minus P, right? So what are we going to get from here? We are going to have R is minus 102 minus P is minus 1 minus 1. And this is going to give us 0, minus 1, and 3. Good. Then PQ is going to give us Q minus P. Q is 236. Is it minus 6? Yes. And then P is minus 1, 1 minus 1, as we know. Oh, what is P? P is minus 1, 1 minus 1. Okay. So this is going to give us 4, 1 minus 5. Is that right? Yeah, should be minus 5. Okay, yeah, because 6 minus, this will be positive and become 5 here. So now let's do the cross. Let's do the cross very fast. PR cross PQ. This is going to be IJK. So the component for this one is 0, minus 1, 3, and this one is 4, 1, minus 5. So let's go I. I is going with minus 1, 3, 1, minus 5. Minus J. J is going with 0, 3, 4, minus 5. And then K is going with 0, minus 1, 4, 1. So that's what we are going to get. Let's try and expand. This is going to give us equals I 5 minus 3 minus J. This is going to be 0 minus 12 plus K, and this is going to be 0 plus 4. So this is going to give us 2I plus 12J plus 4K. So 2, 12, 4. 2, 12, 4. Let's see if we have the results there. 2, 12, 4. Okay, we have it here. 2, 12, 4. Now, the question 14 is asking us to find D. It's asking us to find D. It's asking us to find D. So how can you find for D? So let's try and then figure it out. Let's try and figure it out. So what we can do here is, now what we need to remember is, like, we have a formula that goes with ax plus by plus cz is equal to d. Remember, anytime, for example, let me go back and show you something here. When we are talking about normal vector, we saw something that we ignored, right? So with the normal vector here, good. So we said that, you see, this is what we are talking about here. So this is the plane. So this is like ax plus by plus cz is equal to d. And what did we do? We ignored the what? The d. We ignored the d. And remember, this is the normal vector, which was here. So the one that we found here is the normal vector. So let's use the normal vector to find for what we are looking for, right? So what did we get to? Question 14. Good. So now when you compare this to this becomes the normal vector, because now this is our A, B, and C, because this is the normal vector whenever you do cross of two planes or two vectors. So A is 2, so I'm going to have 2x, right? I'm going to have 2x plus 12y plus 4z is equal to d. Now, how can I get a d? I'm going to pick one of the points. I'm just picking any of the points, either P, Q, or R. Then I'll just do substitution and see what I'm going to get. So I'm picking P. P was minus 1, 1, and minus 1. Is that right? Yes. So just plug them in. This one is X, this one is Y, this one is Z, and find for D. So this is going to give us 2 times minus 1 plus 12 times 1 plus 4 times 1 is equal to D. So minus 2 plus 12 plus 4 is equal to D. And when I add, this is going to give us 14. So D should be equal to 14. Is that right? Oh, this one's supposed to be minus. Okay. So it means that this is going to give us something like 6. Yes. So D should be equal to 6. We have 6 there. Yeah, we have 6 here. So that is basically what. So please note that this one is very, very important. This formula here to find your constant D. Let's look at question 15. Let's look at question 15. So find the magnitude of A minus B, given that we have two vectors A, B, and they've given us the magnitude of 2, which is this, and magnitude of B, which is equal to this, and A dot B, which is equal to 4. So record that magnitude of this squared is equal to A squared. This is something that you need to remember. If you remember this, then you can do this one. So this implies that magnitude of A minus B squared is also the same as A minus B squared. Good. Then what can we do here? What can we do here? Now we can write this one as magnitude of, let me see. We can write this one as magnitude of this squared to be equal to. Now this is the same as A minus B dot A minus B. So expand this one is going to be, this one is going to give us A dot B, sorry, A dot A, multiply this and this, minus A dot B, minus another A dot B, plus B dot B. So A dot A is the same as A squared, minus this is 2A dot B, plus B squared. Now, since A's magnitude of this is the same as this, then we can write this one as that, right? So this is also the same as this. So it means that this small a can be written as magnitude of A squared minus 2A dot B plus magnitude of B squared. Don't forget, this is A minus B, or magnitude. What do we need? We need just this without the square. So we can take square root on both sides. So A minus B squared is equal to square root of this minus 2A dot B plus B magnitude squared. Indeed, we have magnitude of A, B, and A dot B. So we can plug them in. So magnitude of A is 2. So I'm going to have 2 squared minus A dot B is 4 plus magnitude of B2 is 2. Is it 2? Yeah, it is 2. So what are we going to get from here? We are going to get 4 minus 8 plus 4. Oh, okay, I think there is a mistake here. This one is supposed to be, the B is supposed to be 3. Yeah. So B is 3. Okay. So if B is 3, this is going to give us 3, and this is going to give us 9. So that 4 minus 8 will be minus 4 minus 9 is 5. Good. So we are going to have this right here. This right here. Now let's look at 16. I love 16 a lot. Now 16 is basically like we need to look at how to find the parametric form, right? We are going to form the function in its parametric form. I think with this one we've done some before, but let's also go through again. So we want to write the equation of the line which passes through this point and this point in its what parametric form. So since it passes through this before this, now this is kind of going to be something like we need to find this one. The question did not say it is parallel to. So what we just need to do is we are going to have our R, which is equal to, so this one is in terms of t. So R of t will be equal to the initials, which is P, plus here we are going to pick vector PQ with respect to t. Yes, because we need to pick something like this before we can have the vector. Because if the question was saying that it passes through this and is parallel to this, then we can write this one as P plus QT. But it passes through this and this, then this is the initial point, which will be here, plus finding the vector of this, and then just putting it there. So let's find vector PQ, which is the same as Q minus P. So Q is minus 1, 0, 4 minus p is 3, 2, and 6. Subtract minus 4, minus 2, minus 2. So this is what you are going to get. This is what you are going to get. Now, what we can do here is very simple. Now, we are looking at the options before we come through with the solution here. So we are going to reduce this to its reduced form. Like we are trying to reduce this to its simplest form. So I can factor minus 2 out, and this one will be 2, 1, 1, right? And I can write this one as 2, 1, 1, right? So that is how I can write this one. Then now R of t will be equal to P is 3, 2, 6. So 3, 2, 6 plus T. Now T of vector PQ. I've reduced it to its reduced form. This is just a constant. Just ignore that one and then we take this one. When you are doing linear algebra in level 300, you will understand how you can ignore this one. So 2, 1, 1, and then this is going to give us so 3, 2, 6 plus 2t t, which is equal to, add component to component. So I'm going to have 3 plus 2t, 2 plus t, and 6 plus t. Now, what is the solution here? So now remember, don't forget that we can write this one as, can I move this one here small so that I don't create another space? Good. Now we can write this one as, now the R of t can be written as x, y, z, and this is the same as 3 plus 2t, 2 plus t, then this one's supposed to be 6 plus t. 6 plus t. Now I know somebody is still asking question, why did you factor the minus 2 out? I could have maintained the minus 2, but looking at the option, I don't have component that's going with like something like this. Minus 4, minus 2, minus this one inside the question, right? We don't have anything like minus. So look at the options, and then because of that, I need to factor the minus 2 out, which is possible, but it depends on the question. If it is session B and you forgot to factor this one out and use to solve, it is right. But since it's an option, we have the options here. You cannot say there is no results because there is answer there. So let's go for this, this, and that. So 3 plus 2t, then 2 plus t, and 6t. Okay, this one is going to be right here. So 3 plus, so x is equal to this, y is equal to this, and z is equal to this. So 3 plus 2, 3, 2t, and then 2 plus t, and then 6 plus t. That's what you are going to get. All right, I'll leave question 17 for you to do, right? So do the A cross B and then find the magnitude and put your answer in the comment section, right? Put your answer in the comment section. Now let's solve question 18. Very interesting. Question 18, I love it. So we want to find the angle between these two lines and then a plane, right? So that's basically what we just need to do here. Now what we are going to do is, for us to find angle between line and a plane, we need to have two components, two vectors, right? So first we can write out our normal vector. So let n to be equal to the normal vector or normal of the plane. So my n will be equal to 2i minus j plus 3k. So we are going to ignore this. So the one that we found for d, you see that this one, d will be equal to, when I move this one here, d will be minus 1 from here. So this is my n. I need another vector that I can use it to dot this and then find the angle. So I need to combine this one together. So I have this line here, I have another line here. So I'm going to write this one to us. Let me see, the first one is A. So I'm going to have x plus 3y minus z plus 3, right? And this implies that small a is equal to I plus 3j minus k. Then I can pick the last one to be b, which is 2x minus y minus z minus 1. And this implies that small b is 2I minus j minus k. So for me to get another vector, what I'm going to do is I'm going to find vector AB, which is small b minus small a, so that now I can use this and this to find the angle. So let's do that. I'm going to have 2I minus j minus k minus I plus 3j minus k. So 2I minus j minus k minus I plus minus 3j plus k. So this is going to give us I minus 4j, and then k, that place will just get to 0. So now that we have this and then we have this, now we can go through the process. So we know that for finding the angle n, this dot, the normal, should be equal to the magnitude of this times this cos theta. And we've done this one, and this one is not difficult to see that cos theta is the same as this dot this divided by magnitude of this, magnitude of n, and then our theta will be equal to cos inverse of everything that we have there. Cos inverse of AB dot this divided by magnitude of AB, magnitude of n. Good. So now let's find magnitude of A. Let's find this one. So this dot this is equal to, so this is I minus 4j dot n is 2, 1, 3. 2 minus 1, 3. Good. So that is that. Let's try and dot it. So this is going to be 2 plus 4 plus 0. So this times this, and then this times this. There is no j here, so here j is 0. Sorry, k is 0. So 0 times this will be giving us 0. And this is giving us 6. Let's find magnitude of this. So magnitude of this, remember this one is this. So we are going to have 1 squared plus minus 4 squared, which is equal to 1 plus 16, and this is equal to root of 17. Let's check the other one too. This one is the one here. So we are going to have 2 squared minus plus minus 1 squared plus 3 squared, and this is equal to 4 plus 1 plus 9, and the square root of 14. So if we want to find this one first before we go and put them in, this is going to be root of 17 times root of 14, which is equal to root of 238. Now let's find theta. So now theta is equal to cos inverse of 6 divided by square root of 238. And point this one on the calculator, and we are going to get something like approximately 67 degrees. Now what we are going to do here is, now here we need to have two angles. So first we are going to subtract 68. So let's go and check the answer first. Okay. So first let's subtract 67 from 360 to get 1. So 360 minus 67 is going to give us 293. Then we pick the one which is less than 90, we subtract it from 90, and the one which is greater than 90, we add it to 90, right? So we see that this is less than 90, right? This is less than 90, and then we have this one which is greater than 90. So since this one is less than 90, we are going to add it to 90. So theta 1 is going to be 90 plus 67, which is going to give us 157. Theta 2, now this one here is greater than 90, so we are going to subtract 90 from this. So let me put it again. If it is less than 90, you add it, but if the angle is greater than 90, you subtract 90 from it. So this is going to be 293 minus 90, and this is going to give us 0. So let's go and check which one is there. Let's go and check which one is there. So 157 and then 30. This one, which one is there? Okay, we have this one here. So we have the 157. So here, even if you didn't subtract this from 90, you should have gotten it right. You just add 90 to this one, and then you get to the 157 right there. So that's question 18. Let's look at question 19. Let's look at question 19. I love question 19. So question 19, we want to eliminate the arbitrary constants a and b from the equation. So giving us this plus this and y plus b, what we can do here is we can just multiply through. So x times y plus xb plus ay plus ab. Then we just start differentiating. So looking at the options, we need to differentiate z with respect to x till the constant gets to 0. So let's first start with differentiating this with respect to x. When I differentiate this with respect to x, I'm going to have y. With respect to x, I'm going to have b. There is no x, so this is going to be 0. Still, I have the constant in it, so I need to differentiate it again. So differentiate this one again with respect to x. And then now there's no x, so everything goes to 0. Then I need to go with respect to y2 as well. So partial of z with respect to y. This is going to be s. There's no y0. There's no y0, so to be left with this plus a. I have the constant a in it, so I need to differentiate again. This with respect to y, squared, y squared, and there is no y, so this one goes to 0. So it means that when we add the two, it should be giving us 0 plus this divided by this z. This is equal to 0 because it will be 0 plus 0. So this is going to give us a big A from here. We are making it small. Let's continue. So this one, we want to find unit tangent. Wow. We want to find a unit tangent to the curve, and then we find A dot R, then we find R dot V, and then R cross A. So let's do that. Now first, we need the formula for the unit tangent. So unit tangent is equal to R prime divided by magnitude of R prime. And what is R? R, we need to form the parametric equation first. So what is the parametric equation? R is equal to xi plus yj if it is in 3 direction. Okay, we have z there, so zk. So this is the parametric equation. X is cos u I plus y is sin uj and then uk. Now don't forget the function is in terms of u, so this is r of u. So when you are finding r prime, we are going to find r prime with respect to u. So let's do that before we talk about unit tangent. Let's find r prime. So r prime, when I differentiate cos, I get minus sin ui. When I differentiate sine, I get cos. And when I differentiate u with respect to u, I just get 1. So before I come here, I need the magnitude of r prime. So let's do that. Magnitude of r prime is going to be square root of minus sine squared u. Minus u squared plus cos u squared plus 1 squared. So this is going to give us sine squared u plus cos squared u plus 1. Sine squared cos squared is 1. So I'm going to have 1 plus 1, and this is going to give me root 2. So everything is set. So this is going to be minus sin u I. Let me change this one to red so that then plus cos u j plus k. All divided by root 2. So let's go and see if the answer is there. Okay, the answer is right here. So that's what we are going to get. Now the next question is we want to find r dot v. So we have r here, and don't forget v is, okay, they give it to you. The v is the velocity. So since we have the velocity here, we need to multiply it by r. But don't forget, velocity is the same as r prime. So this r prime here is v. When you differentiate the parametric equation or the position vector for the first time, you get velocity. So r times, let's look for r dot v, which is the same as r dot r prime. So r here is cos u I sin u j plus uk dot r prime is minus sin u I plus cos u j plus k. So let's see what we are going to get from here. So this times this is going to give us minus cos u sin u plus this times this is going to give us sin u, or let me say cos u sin u, and then this times this is going to give us plus u. So this will cancel this, so we are going to have u. So let's see if we have u there. Okay, we have u there. Now the last one that we need to do here is we need to find r cross a. What is a? A is the acceleration. Now acceleration is when we differentiate the position vector 2 times, or when you differentiate the velocity. So since we have this one, we need to differentiate it again to get acceleration, right? So let's move it up. So we need r prime prime. Differentiate this, you get cos. Differentiate this, you get minus sine. And then when I differentiate it, this one will be constant, so 0. So this one becomes the acceleration. So we need r cross this. So let's do that. So we need r cross a, which is the same as r cross r prime prime. This is the same as I. So r component, first component is cos u. J component for r is sin u. And the k component is u for the r. So r is cos sine u. This is minus cos sine. Minus cos minus sine. So this is minus cos minus sine. There is no k component, so this will be 0. So now this is going to give us I. So we have sine u minus sine u minus j. This is going to give us cos u minus cos u plus k plus k. This is going to give us cos u sin u minus cos u sin u. So let's try and simplify this and see what we are going to get from here. So indeed, this time this is going to be 0. So we are going to have I 0 plus u sin u. Is that right? Yes, that's true. Then we are going to have minus j. This time this will be 0, so this time this is going to give us 0 plus u cos u. What are we using? We are using r and a. Okay, that's right. We are doing it right. Okay. Okay, so let's continue. And then plus k, and then this times this is going to give us cos u sine u plus 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 cos u sine u. I hope I'm doing the thing right. Let me see if I arrange this one right. So I have r prime prime. What did I get for r prime prime? Minus minus, right? That's the acceleration. We are looking for r cross. So this is r. So cos, and then everything is minus minus 0. So cancel this. We have this one here, which is right. Cancel this, and we have this and this here. Cancel this, and we have this, guys. So this one's supposed to be minus. So this is going to be minus, and put minus here. So now this is going to give us u sine ui minus u cos uj, and this one will be 0. So it will just be going to 0. So let's see the answer that we are going to get for the options. Okay, so we are going to have this. Is that right? Okay, sine first before cos. Okay, indeed, that's right. So that's what you are going to get for the option. Now let's look at 23. You're almost done, then I'll give you some to try. Let's look at 23. So 23, we want to find the partial differentiation y squared and x. So this one, when you are doing this differentiation, this is how you start. You start from this, right? So you start from x and move towards y. So first, x is 1, so you are going to have squared of this divided by y squared in brackets, partial of this with respect to x. So this is how we can write it. So you pick one of this line. So when I multiply this one by this, I'll get 3, and this and this. So it means that I'm going to have partial squared over y squared. Then I need to differentiate this with respect to x. But what is this? This is what is here. So I can write this one as 4y squared x to the power 3 plus 3xy cubed z minus x squared plus 2. So let's differentiate and see what we are going to get. Partial squared over partial y squared. Remember, we are differentiating with respect to x. Anything which is not x gets to 0. So this is going to give us 12y squared x squared plus 3y cubed z minus 2x. And then when I differentiate 2, I get it to 0. So that's what I'm going to get. Now let's look at the next one. The next one is now we differentiate this. It means that we need to differentiate now with respect to y 2 times, right? We need to do it to y 2 times. So this is going to be like this. Now partial of with respect to y, and then now y goes inside. So this, and we differentiate 12y squared x squared plus 3y cubed z minus 2x. Good. So now we are going to differentiate this with respect to y. So this is going to be partial with respect to y. So with respect to y, we differentiate y, and we are going to get 24y squared plus 9y squared z. There is no y, so that one gets to 0. That one gets to 0. So now let's finish it up. Now we differentiate what is left with respect to y. So we are going to have 24 x squared because I differentiate the y. Differentiate this and we are going to have plus 1 8 yz. Good. They've given us some point, which is here 1 minus 1 2. 1 minus 1 minus 2, I think. Yes. So plug them in. This is x, this is y, and this is z. So we are going to have 24 times 1 squared plus 18 times minus 1 times minus 2. And this is going to be 24. Is it going to be plus? Yes, plus 36. I think so. And this is going to give us 60. Yes. So we have the big 60 here. Now let's look at question 24. We are almost done. We have like 7 questions to go. So let's look at this question here. We want to find the magnitude of, after when we are done this one. So let's first find the r over the t. So we want to differentiate this with respect to t. So let's do that. This, we are going to use the product rule. So for the first term here, product rule, I maintain e to the power minus t and differentiate cos t. I'm going to have minus t, then plus I maintain cos t and differentiate e to the power minus t. I get minus e minus t with I. So this is just for the I one. Then I go to j. I use product rule again. I maintain e to the power minus t and differentiate sine t and get cos t, plus I maintain sine t and differentiate e to the power minus t and I have minus minus t. This alone is j. Then I go to k, direction, and I'm going to have this one to be minus e minus t k. Now, we don't want to make things so complicated, right? We don't need to find the magnitude before we plug in 0. So this one, since we have the point, we can plug in t is equal to 0 before we find the what? The magnitude. So that's one trick that we can use here. So before we find the magnitude, let us plug in t first. So when I plug in t here, I'm going to have e to the power 0. Sine 0 is 0, plus cos 0 is 1, and then this one will be minus e to the power 0. So this will be the I direction. Now j direction, we are going to have, this one should be plus. We are going to have e to the power 0 because t is 0, and then cos 0 is 1, plus sine 0 is 0 times e to the power 0. This is j direction, and this is going to be minus e to the power 0 k direction. So simplify this, we are going to have, this one will be 0, this will be minus 1. So we are just going to have minus 1, which is times I. So we are going to have this I. This goes to 0, this will be 1. So this is plus j minus k. So you see that this has become so simple for us to just find the magnitude. So now the magnitude of this with respect to this at t is equal to 0 is going to be minus 1 squared plus 1 squared plus minus this. I think this should be given as 1 plus 1 plus 1 and the square root of 3. So if you don't do that, if you don't substitute t first and you try to find the magnitude, you are going to get the same thing, but it's going to require a lot of work, right? So anytime you are doing something like that, you see the point. After the differentiation, then you plug in t is equal to 0 before you do that. So this answer here is B. 25. We are almost there. Should I leave this one for you guys to solve? Okay, let me see. 28 is here. Let me see 29 to 20. Okay, so maybe I'll leave 29 and 30 for you guys to solve. Let's solve 25 to 28. So we want R1 dot R3. So let's do that. So R1 dot R3 will be equal to x squared I minus yj plus xzk dot R3 is I minus yj plus x to the power 3k zk. Good. So direction by direction is going to give us x squared plus y squared plus x to the power 4 z squared. So this is what you are going to get, r1 dot r3. We have there, which one is x squared plus y squared plus, so I think this one is supposed to be this one here. So this one is supposed to be C. Good. Now the question is, now we need to find the partial derivative of r1 r3 with respect to x and z. So let's do that. So partial of r1 dot r3 with respect to x and z. So don't forget, this one will go from this to this. So I can write this one as partial of x in bracket partial of r1 dot r3 with respect to z. So r1 dot r3 is what we just found, which is here. So we are going to just put it inside. We are going to have partial of x, and then this is going to be partial of with respect to z, and then we are going to have x squared plus y squared plus x to the power 4 z squared. This is going to delete everything. There is no x, there is no z, this goes to 0, this one also goes to 0. So we are going to have partial of x is going to be 2x to the power 4 z. Now there is no, this one goes to 0, and we just differentiate z squared, and we are getting this. Now we differentiate this with respect to x, and we are going to have 8x to the power 3z. So let's see, 8x to the power 3z, which is also here. Then the next question is, we need to find R1 cross R2. I'll show the trick that you can use here. Now, what you can do here is, first, you can, since this one is a point and you are not differentiating, you can first put the point inside R1 and R3. When you finish, the answer that you're going to get, then you do the cross. It's also going to give you the same thing. Or you can cross R1 and R2 first, and then the answer you put in point 1, 1, 1. So you can do the long one. I want to do the short one. Okay. So what I'm going to do is, this one is section A. So I just want to skip some steps. So for me to find R1 cross R2, I'm going to find R1 first by putting in the point. So put 1 here, 1 here, 1 here. I'm going to have I, J, K. So that's what I'm going to have for this one. So this is going to be I minus J plus K when you plug in 1, 1. Then let's find this R2. What is going to be R2? Put 1, 1 inside. So this is going to be I minus minus. So this is going to give us I minus J minus K. You see that this one becomes very simple to find the cross. So now, since we need the cross, this is going to be I, J, K, 1 minus 1, 1, 1 minus 1 minus 1. So this becomes very simple for us to solve. So this is going to be I minus 1, 1 minus 1 minus 1 minus J, 1, 1, 1 minus 1 plus K, 1 minus 1, 1 minus 1, 1 minus 1. So this is going to be 1 plus 1 minus J minus 1 minus 1 plus K minus 1 plus 1. Yes, that's true. So this is going to be 2I plus 2J plus 0. So this is what we are going to get. Now we need the magnitude. So R1 cross R2 magnitude is going to be square root of 2 squared plus 2 squared, and then 4 plus 4, and this is going to give us square root of 8. Square root of 8 is the same as this. So let's check which one is there, 2 root 2 or square root of 8. Okay, we have square root of 8. So you see that if I don't do this kind of doing substitution first, it's going to make sure that I do a whole lot of work, because I need to be multiplying this x and y together before, when I finish, I plug in the point 1, 1, 1 before I find the magnitude. it's also going to give you the same thing. Now, question 28 is also part of the first one. So, lucky for us, this one too is at point 111. So, we've done R1, R2, and R1. So, let's look for R3. So, R3 is going to give us, plug in this point inside R3. So, when you plug in R3, we are going to have 1 minus 1. The same thing again. So, it's going to be 1. So, it's going to be I minus j plus k. Now R1 we found and we saw that it is I minus j plus k, and R2 we saw that it is this minus j minus k. So now we can just find for R2 dot R1 dot cross R3. So this is scalar triple. So the first one, this one will be up there. So 1 minus 1 1, and then R1. No, what is R2? Okay, this one should be minus. R1 is 1 minus 1 1, and R3 is also 1 minus 1 1. So let's see what we are going to get for that one. So let's do this, and we are going to have something like this. Oops. I pick 1 minus 1 1 minus 1 1 minus minus 1. I'm going to have 1 1 1 1, and then plus k. I'm going to have 1 minus 1 1 minus 1. So this is going to be 1. This is kind of like getting to 0. So minus 1 plus 1 plus 1, 1 minus 1 plus minus 1 plus 1. So this one will be 0 plus 0 plus 0, and this will be 0. Okay, let's see if we have 0 there. Okay, we have it there to be A. So you see that if I don't plug it in, you are going to do a whole lot of work before you get the result. Mind you, this is an objective questions, and you need to make sure you work around where you are going to move very fast. So now solve question 29 and 30, and then leave your answer in the comment section. I think I left one question to there, so solve all of them and leave your answer in the comment section. Now don't forget the formula for this. The formula for this is I think you know it. Okay, you know it, so you can just do it and leave your answer in the comment section. So in the next video, we are going to talk about the subjective, that is section B of vector algebra, right? And then we are done with the course. So see you in the next video.